Hello, I'm Reggie York. I'm doing a presentation on using the York Excel file for the binomial test. That is when you are comparing post-test data measured as a dichotomy to a threshold proportion. Dichotomy means it has only two categories. This is an illustration of how to use that file for computing this particular test to one particular application of that test. So we'll have an example we'll use to show you how to use that file when you need to use it. There are other applications of the binomial tests that are the subject of other special Excel files by York. We are only going to talk about one of them. The binomial test illustrates to us the likelihood that chance explains the differences in the frequencies for two categories when these frequencies are compared to a threshold fraction. We will illustrate that in just a moment. This application of the binomial test is when you have measured your dependent variable as a dichotomy, such as whether or not your homeless clients found a home within 6 months. They either did or didn't. That's dichotomous. You have a national norm for comparison, such as the fraction of, say, 0.25 or 25% of homeless people who have been found to normally find a home within 6 months without your special service. So here is your hypothesis. The proportion of our clients who find a home within 6 months will be greater than the national norm of 25%. What you need is the special Excel file that is available with this book illustrated here. The specific file is York number 8 binomial test, post-test data compared to a threshold proportion. Here is the data you'll need when you load that file and do your analysis. You have to have, first of all, the number of your clients who are in the favorable category at post-test. In our example, they found a home. Number two, the number of your clients who are not in the favorable category at post-test. In other words, did not find a home. Or another way to put it is, what was the total number of your clients who were in your study? So instead of the number 2, it should be the number of clients in your study. The number 3 is the fraction that is a threshold for comparison. Here's an example. At post-test time, 17 of your clients found a home and 8 did not. So we have 17 out of 25 who succeeded. Let's say that the national threshold, which is hypothetical, is 0.25, or 25% normally do. Well, your number, 17 out of 25, is higher than 25%. The question that becomes, is it statistically significantly higher? Now let's look at the particular file. Here is the file. There are instructions up here showing you, in fact, it shows the example of that we're going to use where we're comparing the number of people who had a favorable outcome with the threshold. So the first thing right here, enter the number of favorable post-test recordings, put it here. The number of favorable in our example is 17. That is to say, 17 of our clients found a home within 6 months. Enter the total number of post-test recordings. In our case, it is 25. So we have 17 out of 25 who were successful. Here is where you put the fraction that is the threshold. And here we find that the number is 6.3 E-606. When you see a E-06, that means you move the decimal place 6 points to your left. So instead of 6.3, it is 0.006.3. So this is statistically significant because it's much less than 0.05. I hope this will help in using this particular file.